Alright, for our next word problem, we're going to do another distance rate time problem, but with a little twist. So Charlie begins a run at an 8-minute mile pace. 10 minutes later, Danielle leaves from the same point at a 6-minute mile pace. When do they meet? Well, first of all, we have a problem with units. In order for us to do any distance rate time problem correctly, you need to have the rate and time be the same as your units of distance. Well, we have minutes, but minutes per mile doesn't really work as a very good rate. But if someone can run 8 minutes to 1 mile, then it stands to reason that they can do 1 mile every 8 minutes. Or they can, or more appropriately, they can travel 1/8 of a mile every minute. Similarly, 6-minute mile corresponds to a 1/6 mile per minute. And those units work nicely with our units of time because we can multiply by that unit of time, a minute, and get total miles. So with that adjustment, we're ready to go. So Charlie's rate is 1/8 and Danielle's rate is 1/6, a bit faster. Okay? Now at this point I haven't defined a variable, so let me do that. T is equal to time elapsed since Charlie began. Now if you want to make it the time elapsed since Danielle began, that's all well and good. You are permitted to do that. Just understand that the time has to be adjusted for one or the other. So I just arbitrarily chose Charlie as our absolute time. So his time is T. The amount of time he spends on the road is exactly T. Now for Danielle, she started 10 minutes later. So if Charlie's been on the road for 15 minutes, that is T equals 15, well Danielle's only been on the road for 5 minutes. Well, the connection between 15 and 5 is that it's T minus 10. So T minus 10 goes in here. Now we multiply across. 1/8 T is equal to 1/6 of T minus 10. Now I said that they're equal, and we know that because the question is asking when do they meet. So when they do meet, their two distances will have been equal. So I now have an equation for each of their distance, so I just set it equal and solve. So 1/8 T is equal to 1/6 T minus 10. So 1/8 T is equal to 1/6 T minus 10/6. It's at this point that I'm going to buckle and have us multiply by the LCD. The LCD of 8 and 6 would be 24. So multiplying everything by 24, I'm going to get 24 over 8 is 3, so 3T is equal to 24 over 6, which is 4, so 4T minus 4 times 10, so 40. And it's at this point that I think I'm running out of room, so I'm going to start up here. So basically I subtract 4T. 3T minus 4T is negative T, and that equals negative 40. So just divide the negative, T equals 40, and our units were in minutes, so 40 minutes. So Charlie's on the road for 40 minutes, Danielle's on the road for 30 minutes, and the total distance that they've traveled is 5 miles. I know that by multiplying 40 times 1/8, or similarly 30 times 1/6. So 40 minutes.